Grade 9 review, part 1. Read your mind. Expanding and simplifying algebraic expressions. This may be a complete review. It may be a partial review where as I'm doing it, you start to remember things that you knew. Or maybe it's like brand new. It's like we didn't really do enough of this in my particular grade 9 class. Well, that's okay. I'm going to teach it all three ways. I'm going to go after all three people at once. Algebraic expressions consist of a sequence of terms. Terms are the product of a coefficient and a variable. So each term in there has a coefficient and a variable. Always. Like when you see that first term, 6x, it has a coefficient, 6, and has a variable, x. And even when we see just x by itself, there is a coefficient out there. Let me just make a note over there. If you just see x, what's the coefficient? 1, yeah? Okay, so just a little note there. We get a little lazy when we're doing just x and we leave the 1 out. And the reason we do that is because 1, when multiplied by x, just gives x, so why not just leave it out? I don't know if it's a good idea or not. Even after all these years, I'm not sure it's a great algebraic move. It messes people up a little bit. Anyways, then the terms are separated by addition and subtraction. This is the part that some people miss the first time through algebra. The terms are separated by adding and subtracting. That's how you know what the terms are. Anytime you see an add or subtract, you're moving on to another term. This is really going to matter to us in algebra when we're identifying what's a term and what's not a term. Addition and subtraction divide up the terms. Like terms have the same variables with the same exponents. Ooh, we're going to talk a lot about like terms. And the distributive property is used to eliminate brackets. I didn't explain any of that stuff, really. I just said that's what we're going to talk about here. For instance, when you get an expression like 6x plus 8 minus 4x plus 2, we can do a lot better. We can simplify those things up. And I'll do the first level by underlining. Did your grade 9 teacher do this? I love this move. Underline those two terms. Those are like terms. 8 and 2, we didn't need a fancy algebra class to add 8 and 2. I know what 8 and 2 is, so I can put those two things together. They are like terms. However, 6x and negative 4x are not like terms. So I'm going to underline those using a different type of underlining. 6x minus 4x, those are different types of terms. It's not an exaggeration to say this is very confusing because we don't know what x is. Maybe x is 10, and this is 6 times 10 minus 4 times 10. Do you see why I can't add it with 8 and 2? Because I don't know what x is. So how can I possibly add it with the other numbers? I won't be able to. Maybe x is 100, and this is 6 times 100 minus 4 times 100. But I can put those things together. I can go, okay, 6x minus 4x plus 8 plus 2. And if you're really good at this and you think I shouldn't write an extra line there, maybe I shouldn't. Maybe that's a teaching move that I need to look at that and go, okay, the 6x and the 4x go together, and the 8 and the 2 go together. Now, here's the best part of all this. If you didn't really understand in grade 9 why you were doing these things. If x is 100, this is 600 minus 400. They're both hundreds. So I can put them together. If x is 1,000, 6,000 minus 4,000. In fact, I've chose two nice numbers, 100 and 1,000, but any x will work. If this is 6 times 8 and 4 times 8, I can put them together and say, oh, that's the same as 2 times 8. And one of the best moves you can do in algebra when you get confused by the x's is just go, okay, well, what if x is 8? Or what if x is 100? What would I do? And that's where the algebraic rules come from. They come from going, okay, that's fine. I don't know what x is. That's very annoying. But I do know that whatever x is, 6 of that x minus 4 of that x will be 2 of that x, whatever x happens to be. And then 8 and 2, well, you're supposed to know that one. 8 and 2 is 10. This is a very unsatisfying answer. Simplify questions means tidy this up a bit. Very unsatisfying for mathematicians because they're like, well, what's x? You don't get to find out what x is in simplified questions. All you're doing is cleaning things up a little bit and making them simpler to work with. When we do get the chance to solve for x, we'll be happy we simplified this. That's why we do it. We simplify this up, and then when we have to find out what x is, we've done some of the work. Any questions so far? How many people are very comfortable with that? Yeah, you should have seen a fair amount of that. In fact, your grade 8 teacher might have got to a lot of that too, a lot of that simplifying. And maybe I'm just scraping the rust off your brain a little bit and going, oh yeah, I remember we talked about this. Oh good, back to simplifying. So I'm going to do this question the exact same way, explain it the exact same way. This one has a negative 5x squared and a positive 3x squared. And I used my wavy underlining to sort in my head what those were. And then this one has negative 2x and positive 7x. So I'm going to write the extra line. Do I expect you to write the extra line? No, but be careful, friends. Math is not a journey of how few steps I can do this in. I know some of you are like, how can I find a way to write this in the least possible steps and do the least amount of writing? That's a mistake moving forward. I'm not getting all excited and saying you have to show every step in my class. That's not what I'm saying. What I'm saying is just be careful that you're not glossing over your understanding in an effort to go as fast as you can. Okay, negative 5x squared plus 3x squared. I don't know what x is. But let's just pretend x was 10 for just a second. This really helps in understanding variables. If x was 10, then x squared is 100. So this is negative 500, and this is positive 300. I can put those together. They're both the same type of stuff. They're both 10 squareds. And it works if I say 100 squared. If x is 100, then 100 squared is 10,000. This is negative 50,000 plus 30,000. I'm always using tens. Tens is the easy one to just think about for a second. It doesn't matter what x is. Whatever x is, if I add negative 5 of them, negative 5x squareds and 3x squareds, I'll get negative 2x squared. That's better. That's simplified. And when I have to solve this equation, eventually, or I have to solve an equation involving this, I'll be happy I could simplify it. You might be like, we didn't solve any equations with x squared last year. I'm like, I know, we're going to. That's what's coming next. How do we solve equations when there's x squared in there? You did a lot of solving when there was just x's in there. Yeah. And then negative 2x plus 7x, same thing. If x is 10, this would be negative 20 plus 70. I could put them together because they're both 10s. I don't care that they're 10s. They're x's, whatever the x is. If this is negative 2 times 8 plus 7 times 8, that's the same as 5 times 8. Or whatever the x is, and yes, I don't know the x is, but don't forget, and I'm going to circle it here, don't forget, simplify means we're just tidying things up a little bit. Unsatisfying. We don't get the x yet. We'll get there. We're going to get there. Yes, the whole goal is to get x. Absolutely. We want to be able to solve for x. But sometimes we need to simplify on our way to get there, so we practice that first. Do you have any questions about that? All right, I'll do better then. If someone was going to have a question about this, if you predicted what question somebody might have about this, what question would they have? What would the difficult part of this be?
How do you get 2x squared and 5x together?
Ah, now that's a good question. I can't tell whether he's asking that because he thinks somebody would ask it or if he actually is wondering about it. How do I put x squareds and x's together? I give two answers. Okay? My first answer is the answer you should probably take from today. Until I know what x is, I can't put them together. Because if x is 10, the combination procedure will be different than if x is 8. So that's why I'm stuck. I can't put these two things together until I know what x is. However, we will learn how to simplify what we're seeing here in a process called factoring. And you might have seen a tiny bit of factoring in grade 9, but we'll talk about what we could do to make this a little better and deal with it. It'll be a huge job of ours over a couple of chapters we'll take to play around with this and go, okay, I can't really combine those by adding. Is there anything else I could do to simplify this situation? And the answer is yes. I can pull these together a little bit. I can't resist showing you. I can't resist. Don't write this down. This is not tonight's homework. I'm like fast forwarding in a time machine 4 or 5 weeks. I could take that and go, they both have x in them. you see how they both have x in them? One's got x squared, one's got x. And I could bring an x out front of a brackets. And then in the brackets would be negative 2x plus 5. And before your brain explodes, just take a look at what I've accomplished. X times negative 2x is negative 2x squared. X times 5 is 5x. Is that better? You don't have to be convinced yet. You can just be like, well, it's different. I don't know if it's better, but it might relate to what you're saying. It's how am I going to deal with this then? And that's the process. Now, multiplying out the brackets is coming up later in this lesson. So if you're like, I don't even remember how to multiply brackets yet, don't get distracted by me. And factoring, well, that's part of a later chapter. It's like 3 chapters away. We won't even talk about that probably till after March break. So no freaking out, okay? That's how AP classes are different, though. When you ask questions like that, I might go, oh, let's jump ahead and go take a look at other stuff. In academic class, I would have said, you can't combine them until you know what the x is. And I would have stopped there. Okay. I'm hoping little moments like that don't scare you. I hope they excite you. You're like, oh, that is neat. I don't know what's happening exactly. I'm excited to find out about it. You won't find this difficult. This is not, what grade 10s find difficult, this is not one of the things they find difficult once I teach it. Yeah? Great, thank you for that question. Oh, hey. You did it for the belt, did you? No, you didn't even care about the belt. I'm trying to get to some other people's ego. They're like, I want that belt. I'll even let you take it home. Expand and simplify. Okay, you know what? Let's get sidetracked for a minute and be clear about what the heck is going on here. Because I don't know if it's possible to get all the way here and not know what the heck is going on here. Mental math gets a bad reputation. People are like, I'm not very good at mental math. Everybody's good at mental math if you give them the weapons they need, right? I'm not good, me personally, at hoeing a garden until you give me the proper tool. I'm not good at drilling holes in wood until you give me a drill and a drill bit. Then I'm really good at it. Mental math, you just need the proper weapons. And if you don't have the proper weapons, come and see me and we'll talk about it. I'll give you one today. This might open your mind up. If you've done the work to understand up to your times tables, up to 9 times 9, and you're pretty good at them, pretty good, then I can show you with a few tricks how to be able to do mental math and do up to 99 times 99 in your head using what you already know. It'll take a little while, take a few steps, like learning the Rubik's Cube. It's like, okay, just give me one more step, give me one more step, and then we'll go along. So today, I'm going to show you how to do single digit times double digit multiplication in your head with any 2 numbers. Okay? I'll go fairly difficult right off the hop. Yeah? Say you wanted to do 7 times 23 in your head. This presupposes that you already can do up to 9 times 9 in your head reasonably quickly. I don't mean like bang. I mean like, you can get the answer. If you can't do that, I encourage you to get an app on your phone and get up to 9 times 9 going again, because hopefully at some point you had that sort of down pat. All right, to do 7 times 23 in the head, here's the picture you got to get in your mind. There's a rectangle, and it's 7. Brace yourself for this if you haven't seen it before. It's 7 by 23. This is the distributive property. This is where the distributive property comes from. You say, well, I can't do 7 times 23 in my head. So instead, I'm going to do 7 times 20 and 7 times 3. And because it's a rectangle, I can just add the 2 of them together. Now, this is where your prior knowledge comes in. Can you do 7 times 3 in your head? Just ask yourself right now, is 7 times 3, does it pop into your head? If it doesn't, I encourage you to get an app on your phone. Start with up to 4s. Get your 4s back. Get your 5s. It doesn't take as long as you think to get back up to 9 times 9 reasonably quickly. Not that you'd win a race necessarily, but that 7 times 3, it's like 21. 7 times 20. Mr. Todd, you just said we were going to do up to 9 times 9. Now you got 20 there. This is not hard. What's 7 times 2? 14. So 7 times 20 is 140. So the answer to this is 161. You can do that in your head with a little practice. Challenge yourself as you're walking around. Every time you see 2 numbers, single times double, try it. go smaller than this to begin with, and then move up. I've already solved half your problem of mental math, up to 99 times 99. I've given you single times double. It's only practice. It's only practice that does it. But what's actually happening? I didn't do 7 times 23. I did 7 times 20 plus 3. And what I said was I could take this 7 and multiply it by the 20 to get 140. Then I could take the 7 and multiply it by the 3 and add those two answers together. That's what the distributive property is saying. When we do distributive property, what we mean is I can't do BEDMAS here. This is actually extended BEDMAS. BEDMAS would say add first. Go inside the brackets and add first. Okay, x plus 5. I can't add x and 5 because I don't know what x is. I can't do BEDMAS. Distributive property goes, put me in, coach. I use that analogy all the time. I'm coaching a 7-year-old hockey team. Oh my, this is entertaining. These kids are nuts. And when it's their time to go on the shift, I'm standing by the door, and it's like 5, 4, 3, and they're counting, and their skates are shaking, and then I open the bench, and they fall down. They run out of the door so fast. They just, all 4 of them fall on the ice, and then they get up and they go. Like, it's just insanity. How does that relate to what I'm doing here? Like, I can't do anything. BEDMAS won't work here. I cannot add those two things in the brackets. Distributive properties on the bench going, put me in. I can do it. Let me do it. Multiply the 4 times the x. Multiply the 4 times the 5. 4x plus 20. See? It's extended BEDMAS. That's what's going on with distributive property. It's telling you what you can do. When BEDMAS won't help you, distributive property maybe can. Did you see the distributive property before? Does it ring a bell? Is it okay? If it's not, I live in the math help room after your class. Just come and say, I've got to talk about the distributive property a little more. It's just this. Saw a couple people frowning at me. That's a good move. You can frown at me, and I'll just go back and re-explain something. Distributive property says if you've got two things added together, you can multiply by the first one, multiply by the second one, and add later if you want. It actually is breaking BEDMAS. It's actually saying, no, oh, well, you don't have to do BEDMAS. We could do this instead, okay? And maybe it wasn't explained that way before, and you're like, where are these rules coming from? It's like BEDMAS plus, or more like or distributive property. If you're not going to use BEDMAS, you got to use the distributive property. And so the number out front multiplies by each of the terms in the brackets. And it happens here as well. Multiply the 3 out front times each term in the bracket. 3x, 3 times subtract 2. Or is it negative 2? Get ready for the answer to the question. Is that subtract 2 or is it negative 2? And the answer is yes. It's subtract 2 or it's negative 2. It's actually very friendly. If I'm going to put it together with the x, which I can't, it would be subtract 2. If I'm going to multiply it with the 3, it's negative 2. A couple people frowning, like, seems like you're playing games. All right, if you want, it's actually 3 plus negative 2. So it's 3 times negative 2, but I got to add it. So it's actually subtract 6, because it's add negative 6. So no games going on there, no mathematical games. I can explain it fully of what's just happened there, as I just think of the subtract 2 as adding negative 2. Then when I multiply it by 3, it is a negative, and it's adding negative 6, which is the same as subtract 6. So it seems like I'm playing a little magical game there and changing the rules, but it's all okay. Over here, meanwhile, is negative x plus 8. Do the like terms thing, 3x. Subtract an x, which is 2x. Negative 6 plus 8 is positive 2. Negative 6 plus 8 is positive 2. I'm going to say something incorrect, and I need someone to fix it. Are you ready? Negative 6 plus 8 is 2. I thought a negative and a positive made a negative. Wasn't that a rule? Negative and positive, that's a rule. Negative and positive make negative. What's going on? Yes. This is larger, so negative. This is a war going on. It's like negative 6. Oh yeah, positive 8. Positives win, positive 2. This is electrons and protons, friends. How far are you in science now? What are you guys up to? You guys learned about electrons and protons? Negative charges, positive charge, negative 6 charge, positive 8 charge, positive 2 charge. Very good analogy. So what the heck am I talking about? When does a negative and a positive make a negative? That is a rule, but when does that happen? When you're multiplying and dividing. See, these rules are dangerous. So don't get too hard on yourself when they run together a little bit, because somewhere along the way you might have said to yourself, a negative and a positive make a negative. That's absolutely true. When multiplying. I'm not multiplying them here, I'm adding. See, it came up here. 3 times negative 2, positive and a negative became a negative. Some of that just takes practice, folks. Sorry. Some of it just takes practice. If you're like, I don't get any of this stuff, this is the part that drives me crazy, I might just do my practice sheets. It'll be okay. Don't worry about a thing. All right, let's not wait around till tonight to find out you don't know what you're doing. This question's a lot like the previous one, I think. Take a moment, see what you can do. Multiply that out, simplify it up, and we'll take it up in just a minute or so. Just a chance for you to warm up a little bit, get your math muscles back in the game. And I'll check out my attendance sheet. Try to memorize a couple names. Uh-huh. Yeah. Oh, yeah. Uh-huh. Addison moved up. Uh-huh. Oh, well, that's easy. Everybody's here. 2, 4, 6, 9, 11, 13, 16, 18, 24. We're back to 24 again. We were 24. Then we lost a student. We're down to 23. Then we added a student. We're back to 24. So it's exciting. Question?
Can you tell me what this is?
Oh, yes, checking calculators. Let's do that. And the next time I give you a question to do, I'll come around and check calculators. Here's the big test. Here it comes, the big moment. Hit the fraction button. Oh, it's got a fraction display. Yes. If it's got that, you'll be quite happy with it. You shouldn't feel inferior to the Casio. That thing will do everything the Casio does, no problem. Sharp used to be one of my favorite calculators, actually. It wasn't until I started teaching AP Calculus with that Casio that I slowly migrated over and became a Casio person. But I know the Sharps pretty well, too, so don't worry about that. All right, here's what I like to do in these type of situations. I give you a few minutes to work on it. But just in case someone's out there going, I don't even know what to do first, then I go up there and I share the first step. I think this is the first step, actually, is just to draw those arrows on there. I think it's worth it to draw the arrows on there. Even in AP Calculus class, sometimes people forget to distribute because they forget to draw the arrows on there. So when I do that, I get negative 8x plus 6. So check that line, see if you agree with that line. Then, like terms, negative 8x, subtract x. I'm going to make a mistake here, and then I'm going to get someone to explain it. 2 negatives make a positive. So that's positive 9. And 6 and 8 is 14. What's wrong? I like how she's explained that. There's negative 8, which is negative, like electrons, 8 electrons, and now another electron. And she's called it adding. It says subtracting. And see, adding and subtracting, they're a little bit interchangeable. I could think of this as subtracting, or I could think of it as adding another negative. My brain goes right to temperature in this situation instead of electrons. My brain does. And I go, oh, if it's negative 8 out and it goes down another degree, we're down to negative 9. So what's 2 negatives makes a positive? What's that about? Again, when you're multiplying and dividing. So again, if those rules, you filed them in certain spots of your brain, you might have to reach in and go, oh yeah, comma, 2 negatives make a positive when multiplying and dividing. Yeah? Well, here's another one with 2 sets of brackets. 6x minus 2 plus 3x plus 6. It could be you don't need the arrows. I don't know. Use the arrows. There's nothing wrong with using the arrows. AP Calculus students sometimes use the arrows when things get confused. And they go, let me just write this out for a second. So if the situation deems it appropriate, don't think that you're not good at math because you wrote the arrows. No, that's not. No. Good mathematicians know which weapon to use when, and they're not embarrassed to do it. Yeah? And then what do I got? 6x and 3x is 9x. Negative 2 and positive 6 is positive 4. Hold on. If you're out there and I've already started to move too fast for you, you're already like, I don't know why he did that like that. Why is that? That's 6. Maybe I shouldn't be in AP class. Same examples in the academic class. Okay? It's okay if this stuff is like, I got to bring it back together. That's why we're stopping and doing these review lessons. So you'll pound away at the homework a little bit. You'll text me a question. You come to Math Help. You come tomorrow and you ask me a question, and we'll get everything fixed up. It is not time to panic. When will we panic? When is panic time? 2/3 the way through the 11U course. If things aren't starting to get lined up for you, if things aren't going better by then we can have a talk about math and panicking. No panicking here till June. I got news for you. Are you ready? It's big news. Tell the AP class this. Nobody cares about your grade 10 math mark, except your mommy. Yeah? It's all about learning. We have to learn. So mistakes, errors, high marks, low marks, doesn't matter. All that matters is what we learn from it. That is true, for sure. Okay? Maybe your mommy doesn't want me to tell you that. Well, you got to brag at Easter, don't you? Got to have 99 in math at Easter so you can brag to all your relatives. No, you don't. Any questions there on page 2 of 11? Do I have any chance of finishing this lesson today? I don't know. We'll see. Part B, I'm already on to part B, evaluating expressions. Most people like this better than combining like terms. It makes a lot of sense. To evaluate an expression for a given value, replace the appropriate variable in the equation with that value. Now we'll know x. See? In these questions, like, here's x. Use it. Note, always put brackets around the value when replacing the variable. What's this called? What's this called when we put a number in for the variable? It's got a fancy math word. Substitution. Oh, that word's going to come back to haunt you. Substitution. We are going to substitute like crazy in chapter 1. I'm going to show you some crazy substitutions. And to get ready for that, I say, when subbing, just like when you go to Subway, subbing should always have a wrapper. Do you know the wrapper? Yeah, you get your sub and they put it in a wrapper and they put your little name on it. Turkey, bacon, club, there you go. When subbing, wrapper. Our wrapper is a bracket. I don't care what you're subbing or when you're subbing in for X, put a bracket around it, otherwise mistakes occur. Would the mistake occur here? No, not in this particular question. But let's not decide when we're going to put the wrapper on and not. Every sub comes in a wrapper. Yeah? 2 times, and then bed mass. Can we do this 2 times 3? Yes, we can. So bed mass is in. We don't have to resort to the distributive property here. 2 times 3 is 6. Add 9 is 15. Is it okay? Most people like subbing better than collecting like terms. A little more straightforward. But don't forget the wrapper. Yeah? Yeah, okay. Sub in -2. So -4. Put in the -2 in brackets. See, it would matter this time. If you didn't put the brackets this time, you might get the wrong answer. When subbing in a negative, that's when it really matters. To get a little deeper into this, the wrapper's there just in case negatives are involved. So you do the negatives right. Correct, I mean. There, I've put -2 in for all the x's. Now, what is -2 squared? Because it's different than -2 squared. What's this one? -2 squared. +4. This one is +4. Little side note though, negative 2 squared is negative 4. Let me say it again, just in case you're like, what? Negative 2 squared is positive 4. But negative 2 squared is negative 4. See? Exponents jump in this situation. BEDMAS exponents jump in and go, I'm going to square the 2 before you put the negative on it in this situation. That's why the brackets were so important. The brackets tell you, no, this is all one piece. Negative 2. And if you're going to square it, it becomes positive. The rest is BEDMAS. I'll write the steps. I get negative 15. We are going to deal a lot with squaring things this semester. Any questions about that one? Well, no introductory math lesson would be complete without some fractions. And I chose a pretty easy fraction one to get started with. Yeah, not too bad. Yeah, we won't get crazy with fractions today. So, 3/2 sub in the x in a wrapper. 5/4 sub in the y in a wrapper. And then we need some knowledge from somebody. How do you multiply fractions? It's way easier than adding fractions. See, they teach it the wrong way around. I think they still do. They teach adding fractions in grade 7. They teach multiplying fractions in grade 8, the easier one, messing everybody up. You show up in grade 9 and you learned it in the wrong order. Because multiplying fractions is the easy one. What is the procedure for multiplying fractions? Yeah, you multiply the numerators, right? You take numerator times numerator and denominator times, this one doesn't got a denominator. What's the denominator? You can always have a denominator of 1 if you need it. It doesn't change the value of the fraction. So when you're stuck, you can put things over 1 and use that as a denominator. Then we do that. Numerator times numerator, denominator times denominator. See? Multiplying fractions, very nice like that. Now, you could add these fractions by getting a common denominator, but always reduce first. That's going to come up more now. Grade 9, we might not have set you up too bad for that. But in grade 10 and 11 and 12, check to reduce first. If this thing reduces, let's do that. Let's get the number smaller first. Because 6 divided by 2 is 3, and negative 20 divided by 4 is negative 5. And this doesn't have to be a fraction question. That's why we reduce, just in case it's not as bad as we think it is. And I get negative 2. But let's AP this question just a little bit. Just step ahead a little bit. Does anybody notice something weird that happened when 3/2 got multiplied by 2? 3/2 times 2, the answer was, yeah, the 2 didn't change. If you're dividing 3 by 2 and then you're multiplying by 2, I don't say you should do this, but you could have just gone, oh, those are going to cancel out. Multiplying by 2 and dividing by 2 is going to cancel out. That's why we end up with 3. And again, if that confuses you, don't worry about it. You don't need to know that just yet. But I just noticed that about this question. And over here it happens too. The 4's could have canceled here, and I got negative 5. But let's not get carried away. I just mentioned that cancellation sometimes will make your life a lot easier than actually multiplying this out and then dividing out. Because look what we did. We multiplied by 3 to turn around, we multiplied by 2 to turn around and divide by 2, and we ended up back where we started. There was a shortcut available. Whoa, that was fun. I didn't know that I could do that. Questions? Where did I click to make that happen? Down here? Oh, part C solving equations. A lot of stuff coming at you here. I'll give you the homework page later. You can go home, try them out, stress a little bit. Find a couple errors in the homework answers. I've heard there's a couple errors. We made up a new set of worksheets this year. So if you find those errors, don't freak out. Just bring them back tomorrow. When I check your homework, we'll discuss it. And we'll put the errors up, and I'll go right to my source file and fix them up. I've heard there's 2. Huh? Here's some definitions before we start solving equations. Polynomial expression. Polynomial expression. Here's an expression. This is what we were working on before. It's like 7x, oops. Come on, pen. Cooperate. Don't be like that. 7x squared minus 5x there's a polynomial expression. When we're simplifying, we'll get an expression. A whole bunch of variables and numbers and exponents all combined together. However, when we want to solve an equation, we might get 7x squared minus 5x plus 3 equals something. And I put 0 there, but it doesn't have to be 0 over there. That's the only difference between an expression and an equation. Very boring part of the lesson. You're saying, to make an expression into equation, I need an equal sign? Yeah, that's what equation means. There will be an equal sign. It's an important breakthrough, though. We're not just simplifying anymore. We've got a chance of solving this equation and finding out what x is. And that's one of the biggest games in mathematics going, is an equation appears, can we find out the x value or x values? Maybe there's multiple ones. That's new this year. We'll do equations with multiple x values. Now, solving a polynomial equation means determine the value for the variable that makes the equation true, and that value is called the solution. In order to solve an equation, you must isolate. Did you hear that word? They're supposed to have beat you to death with it in grade 8 and grade 9. Isolate the variable. Means get the variable by itself. If they didn't beat you to death with it, that's okay. I'm going to reteach it here in just a second. To do this, perform inverse operations. What are inverse operations? What's the inverse operation to adding? How do we undo adding? Subtract. How do we undo subtracting? Adding. Important note about inverse operations. Operations are their own, when you find the inverse of an operation, the inverse goes back to the original operation. You know, you can go back and forth like that. How about multiplying? What's the inverse of multiplying? Dividing. And so that means the inverse of dividing is multiplying. Those are all the functions you have at this point. There's many more coming. The grade 11 course is called functions. Here's the functions you have. There's more functions coming. Things like sine and cosine and cube root and ln and exponential. You know, there's lots of things coming down the train. But you might have seen this one too. You might have seen, let me just scroll down a little bit. You might have seen squaring something, which has an inverse of square root. So I put that on there just to go, yes, I acknowledge that you actually have another operation out there that you know the inverse of. Not that we'll do too much with that right now, but I do mention that inverse operation is one you have. So you have more than just the base 4 available. Maybe some others. Maybe you've cubed something somewhere along the way, possibly. You know, I mean, maybe you have a little more experience than that. But this is all I want to work with for now. Every step in the equation solving process requires that the same operation be performed on both sides. That maybe is not exactly how you learned it. I'm going to try and teach it both ways at once. I'm going to be doing a juggling act going, I'm going to try and teach both ways you might have learned this at the same time. Each solution should be checked by substituting the values into the equation. Why wouldn't you check it? You should check to see if your answer is right, and I'll show you how to do that. And note, remove fractions by multiplying. Ooh, let's just steal a trick from my daughter, who is a highlighting psycho. She loves to highlight things. Maybe you would like to highlight things. It's a good study technique. When something comes up in the lesson that's like, ooh, that's key. That's a key thing. You get your highlighter out, and she had a coding system. She had 4 highlighters at all times. I forget what her coding system was, but I'll try to remember it. When she highlighted something in yellow, that meant I better look back at this. So I'm going to use that on mine and just highlight in yellow. If you don't have a highlighter, maybe you'd like to underline it in red. Remove fractions by multiplying all terms by the lowest common denominator. What are you talking about? Well, I'm going to explain it in just a few minutes. She used red highlighter for something that scared her, or that she better ask about because she didn't really follow what was happening. And it de-stressed her when she was doing her notes. Like, yeah, I didn't understand that, but I highlighted it. I'm going to ask about it. No worries. I'll talk about it later. Yeah? She's taking biochemistry at university. You should see her notes. It's all highlighted and coded and, you know. Let's just start with yellow, shall we? Yellow's like, it's important. It's important little detail. Solve the following equations. Well, I hope you're good at solving these equations, but I'm going to show extra steps to talk about the steps you might have learned to doing these. 15x minus 9 equals 36. My question, my method of teaching these says, what's the opposite of subtracting 9? Adding 9. So, some of you will write this. This is a good step. The process of solving equations means do the same thing to both sides of the equation. And the same thing I'm going to do is adding 9 to both sides. That is a great step of mathematics. But some of you are too good at it now, and that's okay. You don't think of it that way. You go, well, I don't have to write add 9 over there. I know what's going to happen. Subtract 9, add 9, that's all going to cancel. My next step instead is just going to be taking that subtract 9 and move it over to the other side. So I give you permission to go to either one of these steps. I don't say one's better than the other. Actually, I will say. The first way is the better way. But it's not faster. And you may be so good at that particular step now that you can jump here. But I'm going to tell you, I'm going to keep coming back to that idea again and again over the next 3 years. And so don't underestimate how important that first version is. Then I can simplify. See why simplify is so important? I've got to be able to simplify as I go to make this situation better. Moving the 9 over doesn't really help anything until I simplify by adding those two like terms. You just hear a weird noise? Does anyone hear a weird noise? Or am I losing it? Now I ask this question. What's the opposite of multiplying by 15? Divide by 15. And I'm going to do it to both sides. Most people up to about grade 11 actually like doing this. They don't show the step that I showed earlier, but they do show divide by 15 on both sides. Because what's 15 divided by 15? 1, which I could write 1x, but I don't need to write 1x. I can just write x equals 3. Now let's talk about this checking thing that's going on here. Now would be a good time to check out your calculator. I'll bring up my, Casio crazy calculator that I got on the screen here. Doesn't matter. It'll look like yours as you type in. I'm going to check this answer. Watch this. Maybe you missed this part in grade 9. You can check this answer. What I'm going to do is I'm going to go 15 times 3, subtract 9. 15 times 3. See, I substituted it in a bracket. Just in my calculator the same, subtract 9, and I'm going to press equals. What do I hope comes up on the screen here? 36. That was the whole goal of the exercise. Find the x that when you put it into the equation, you get answer 36. See how good that makes you feel? And I got to check the back of the book. I have to go over my work and check it 18 times to see if I made a little mistake. Check. I'm going to put a little check mark there. Your teacher might have taught you left side, right side check, and I will talk about that. But at least do this. At least go, let me just put this in. It only takes a moment to check the answer. It's probably faster than actually checking your answer. Well, friends, this question might make some people pause, and that's okay, because this is where equation solving, where the game completely changes. That first one's an inverse operation questions. Most people, if they see that a few times, go, oh, I can do the opposite of subtracting 9. I can do the opposite of multiplying by 15. That's not too bad. But this one needs a little more thought. What I'm going to do is first ask, what does the last line of every equation solving question look like? I don't mean what's the answer. What's it going to look like? When I get down to the bottom here, what's going to be there on the left side? X. That's what they're talking about when they say isolate. They're saying get x over there by itself. No 2's, no 3's, nothing. Just x. Isolate x by yourself over there. You sit in the corner and think about what you've done. Yeah? You're going to isolate it. Equals, and then hopefully the number over here. That's what I mean. When you're learning equation solving, I think that's a great move to down at the bottom of your, a few lines down, go x equals, because it helps you understand what you're going to do next. And what you're going to do next is say anything that has x's goes over to the left side. Anything that has numbers goes to the right side. So when I look at this first line and I see subtract 33, I go, negative 33, you're not supposed to be there. You got to get out of there. How do us mathematicians get rid of negative 33? Add 33. So I'm going to show you another way to handle this. I really love this move. It really shows what we're doing. We're adding 33 to both sides. See, we're not changing the equation. You can think of a balance. You ever do those scales in grade 7, 8 where you had to weigh something and you put something on this side and something on that side? That's what's going on here. I'm going to put positive 33 on both sides. That won't change the equation. Won't change it being true or not because I haven't changed anything. But on the left side, negative 33 plus 33, those things cancel. And over here, 9 plus 33 are like terms, so I can put them together. I pause again. I don't know what speed to go. I can't read your minds. If I should be going faster, I would go faster. And I'll get to know you, but I don't know those answers. Maybe some of you actually need me to go slower. You're like, oh, this is the part I had trouble with. He's zipping right through it. It's fine. I think you'll find if you go rewatch the video tonight, things will go well. Or you come see me in the math help room, and we just go slowly over equation solving again. So please do not panic. Please, please, please do not go home if any of this is too fast and think, oh, maybe I shouldn't be in this class. Let's just review. I'm going to do a review quiz later. That doesn't matter. It's just like, where are we at? What do we need to work on? And then we'll go from there. Right? The first lesson that really matters, I'll do on Monday. If at the end of Monday's lesson you don't understand what I did, well, then maybe you can start to get a little worried. But these are just reviews. These are just things that we might use this year, and we better look at them and then see how much we remember and how much we don't. All right. This equation has a major league problem. Does anyone know? Let's identify what the major league problem is. What's the major league problem with this equation? It's got x's on both sides. She says it's got 2x on the right side. Does anyone know how to get rid of 2x? Yeah, subtract 2x. It is an inverse operation, but it doesn't feel the same, like the same kind of inverse operation. Really, I'm trying to eliminate this 2x. I'm trying to go, I don't want 2x over there, and I know how to get rid of it. I'm going to subtract 2x. I'm not allowed to do that to only one side. I've got to do the same thing to the other side. Is this great mathematical form, writing it above like that? No. It is great teaching form, I'll tell you. It really shows what's going on. But you should probably write it like this. Negative 5x minus 2x equals 2x minus 2x plus 42. That's really how you should write it. And if you're so good at these, where you think of it as 2x when it comes over becomes subtract 2x, I'm with you. I don't mind if you skip that step. And your step looks more like this. Negative 5x minus 2x. Two negatives make a positive. When do two negatives make a positive? It's true, but when does it happen? When multiplying and dividing. If those rules have run together, do not panic. Happens all the time. You just have to brush off your skills a little bit, get the rust off them. Negative 5 minus 2. I think of negative subtract. I always think of temperature, negative 5, subtract 2. I'm down to negative 7. And what's the opposite of multiplying? Dividing. Now, this one causes even really smart people problems. You might have memorized a rule that says, when you move things over to the other side, they change sign. And that's not true at all. Yes? Here's what's true. When you move add to the other side, it becomes subtract. When you move subtract to the other side, it becomes add. Take that changing sign thing out of your brain. That was a shortcut. Sort of helpful, but sort of dangerous. That's not what really goes on. Adding becomes subtracting, subtracting becomes adding. That's the part to remember. Because what's the opposite of multiplying by -7? And the answer is divide by -7. So when this one moves over, it stays negative as it goes over. Okay? And then again, that might clash together with how you memorized it. We just got to put a comma there going, we're changing operations. We're not changing signs. And sometimes that looks like we're changing signs when we're adding and subtracting. And 42 divided by -7, ooh, -6. Ooh, this one's got both. What do you have to do first here? Do the distribution first. And I get 3x minus 10 equals 2x minus 6. Well, let's not find out. Let's not wait till tonight to find out that you can't deal with x's on both sides. You try this one. See if you can isolate x onto the left-hand side. And we'll take it up in moments. You won't have to wait long. If you're having trouble with it, just peek up. For my first step, maybe your first step looks a little different than mine. And then wait a few seconds and peek at the next step and see how you did. How'd you do? Did you get x equals 4? If you got a little mistake there, a negative or something like that, not time to panic, just time to go, ooh, a little practice here. Well, let's talk about left side, right side check. Did your teacher show you a left side, right side check last year? Some people nodding, some people shaking their head. That's okay. Left side, right side check is when things get a little harder to check. And what you do is you write down exactly what the left side was on your left side of your check. And then you write down exactly what the right side was from the very beginning. And then you sub in the x you think is the right x to both sides. So this one is 3 times 4 minus 10. And when I multiply that out, I get 12 minus 10. I get 2. Over here, sub in the x, which is 4 minus 3. 2 times 1, which is 2. That's how we check answers when the expressions are a little more complicated. You organize yourself into a left side and a right side, and you sub them both in, and away you go. Questions? I think we're running out of steam here. That's a pretty long lesson for your first time back. So what I'm going to do is hand out the homework pages, and we're going to, no. You got 2 more in you? We'll knock down the last 2? Then at least we're A, B, C. At least we're done there. Okay, so I can see a few of you getting a little drowsy, and that's okay. But I'll reasonably quickly do the last 2. And then you can get at least that far, and then we'll do D tomorrow as part of tomorrow's lesson, and we'll see how far we get in tomorrow's lesson. I'm not interested in rushing these things. Okay, this one not too bad. Distribute the -3. I think this one's, there's another example here because of the negatives. You got to watch out when you're multiplying in negatives. -15 plus 8x equals 39. Plus 18x, sorry. Easy to mess up when you're multiplying negatives in. But this is negative times a positive, which is negative, and negative times a negative, which is positive. So then, get rid of subtract 15 by adding 15. 18x equals 54. And then what's the opposite of multiplying by 18? Divide by 18. Most people like this. Divide both sides by 18 because it looks really neat. And I get x equals 3. Okay. This is the one we better talk about, though. This is what that highlighter was about. So I'm glad we got to this example because equations with fractions are extremely difficult. Extremely difficult. Unless you know what it says in the highlighter. The highlighter says, remove fractions by multiplying all terms by the lowest common denominator. What? All right, I don't know what you're talking about, but I'll do what you say. What is the lowest common denominator when I see a denominator of 2 and 3? 6. So the highlighter says, multiply everything by 6. And what I mean by that is, multiply this whole equation by 6. You're allowed to do that. If you do the same thing to both sides, it'll still be equal. If you want, you're multiplying this side by 6, and you're multiplying this side by 6. It's okay if you've lost faith in me at this point. You're like, this is a disaster. What the heck is going on here? Well, take a look. I've got to do 6 times x over 2, and I've got to do 6 times negative 3. On this side, I got to do 6 times x over 3, and I got to do 6 times negative 5. Let's go back to multiplying fractions. What do we do to multiply fractions? It's the simpler one. No, not cross multiply, but I think you know the right thing to do, but you're saying it wrong. Cross multiply is that ratio type thing. It's, go ahead, say it. Just multiply the numerators, multiply the denominators. See, multiplying fractions is the easiest of the fraction operations. If you need a 1 in the denominator, then you just do it. Yeah? So this one becomes 6x over 2. This one becomes negative 18. This one becomes 6x over 3. And this one becomes negative 30. And at that point, you're like, okay, I'm really losing faith in you now, Mr. Todd. That did not make anything easier. It just made a bigger mess. Why are you multiplying through by the common denominator? To which I ask the question, what's 6 divided by 2? And when you write that, hopefully your eyes light up a little bit like, hey. Multiplying through by the common denominator got rid of the fractions. Almost magically. It feels like cheating. It's not cheating. It's a great mathematical move. Multiplying through by the common denominator in an equation will clear out all the fractions and make your life a lot easier. Same thing happens over here. 6x divided by 3 is 2x. And I've changed those added negatives to subtract. And I don't know. Some of you might be this good. You don't have to do this. You can follow the steps in the other ones. Some of you might have done enough of these that you're this good now that you're like, I don't know why you're showing all those steps, Mr. Todd. This is a pretty simple situation. You bring the 2x over here, and it becomes subtract 2x. You bring the 18 over here, and it becomes add 18. Isn't that nicer? And I'm glad I showed it today because, yes, for some people, that's actually easier than what I showed before. And I get x equals negative 12. Today's lesson then will be a 2-part video. The reason I'm talking like that is anybody watching this video, there's going to be part D, and that second part of the video will be on tomorrow's D2L.